everyone, and welcome to another Risky Business product demo. My name's Patrick Gray. And we've got a special one for you today, one that is near and dear to my heart. Knocknoc, which is a company that I advise. I'm in fact on the board of directors of this company. And Knocknoc makes, I guess, what is best described as a access control platform. Probably makes sense to explain where it came from before we explain where it is now. So initially, Knocknoc was basically a platform that would allow you to instrument your firewalls to allow for dynamic allow listing, right? So the idea is you can take a resource like a server or a service, firewall it off from the world, and then you can selectively open up to a user's IP when they have gone through some sort of authentication challenge. Now, the really cool thing is here, we have a uniform way of doing authentication challenges via services like Okta, Entra, even Google, whatever. SSO is a thing now. So what Knocknoc does is a user goes through SSO, they hit their Knocknoc page, select to open a resource, and then bang, their IP is allow listed to that resource, even by port. So they can access that port and do whatever task it is that they need to do. So we use it at Risky Biz HQ, our content management system for our website. We don't like that being open to the entire internet, right? So we firewall it off. And when we need to post a story or a podcast or whatever, we just hit our Knocknoc page and hit grant access, and then we can access it for a certain period of time. So that's where Knocknoc started, which was just around IP allow listing, dynamic IP allow listing, just-in-time network access, whatever you want to call it. But these days, it's bigger than that. You also have a identity-aware proxy component, which is going to be part of this demo. And you can even do stuff like pump RDP through Apache Guacamole, through an authenticated web session, which is extremely cool as well. Again, it's going to make more sense in the demo. So at this point, I should probably introduce Adam Pointon, who is the chief executive of Knocknoc. Adam, how did I go with the explanation there of what Knocknoc actually is?
It was pretty good. It's pretty good. It is different to other systems and technologies out there, but yeah, you nailed it. I think it's the just-in-time, default deny, open it up based on IP address and more, as you said, we'll see. But yeah, access control, just-in-time. In a nutshell, you summarized it really well.
So, I mean, like, something to keep in mind, right? Like, if you are just doing IP restrictions on certain things, so some people will use it to IP restrict their horribly vulnerable VPNs, right, at the ingress points to their network. Now, that's not a complete solution for the issue of those things getting compromised, but it certainly reduces your exposure and does it in a way that's really easy to implement. And indeed, we'll be showing some of the sort of admin features of this product as we go. Other use cases, so, protecting devices at the edge of a network is a use case. It's turning out to be very popular in OT and ICS environments where people have an IT network and an OT network and they don't want those things connected all the time. But it's nice to be able to hit a button and then the firewall gets out of the way. They can do their administrative task and then revoke that access. So that's another use case. And then you've got, just controlling access to internal resources, external resources, web applications through the ID-aware proxy, RDP, SSH, whatever it is. So in this demo, I believe you're going to walk us through, to begin with, the user's perspective, like the user experience for just a typical corporate user who's trying to access resources through Knocknoc. So take it away, Adam.
That's right. So as you described, the demo starts off with the end user. So this is the person that needs to get access to the content management system or to SSH, whatever it is. So there's a web application component. We host it, self-hosting. You can host it wherever you like. And this is what it looks like. So we're tied in with an identity provider here, or there are local users, which we'll sort of talk about later. So I click login. We're using Authentic in this example. And I've now logged in. So as you can see at the top, hi demo user, I'm from this IP address at the moment, and I have 7 hours of access. That's the default that it is allowed for my user, obviously configurable. And there's various cards here that have back-end systems that I can then access. So ping, we'll talk about this one first, but ping is a simple example that shows how Knocknoc is orchestrating access through to allow me to send ping packets to a particular host. So let me just bring up a shell here. So I'm pinging this server directly from my machine and I get a response. Now, if I log out, you'll see immediately connection's blocked. So ICMP is no longer able to get through to this backend server. Click login again, goes through the IDP process, and bang, I've got network access.
Yeah, so I mean, all that's happening here is you've essentially glued an SSO-backed automation to a firewall that means unless you're logged in through here, you just don't get network access.
That's right. This is what's sort of happening on the back end at a higher level. So on the left, we've got the Knocknoc web application, the server. It happens to be hosted in Sydney. My user's in the middle. I log into the Knocknoc server tied to the IDP. And then on the right-hand side, in this case on-premise, there's a firewall, happens to be a Palo Alto. There's a Knocknoc agent, and that Knocknoc agent is subscribed to the server for events. In this case, when my user logs in, it tells the agent, Adam is logged in, he has access to be able to ping this backend server. So the agent then goes and talks to the Palo Alto firewall and says, add Adam's IP address into the policy, which allows the ping to go through to that backend server. So it's not changing the firewall policy, it's just adding or removing IP addresses and other information we'll get to later into that firewall control that then allows me to ping that backend server.
Yeah, so I mean, just to be clear, it's not adding like some new firewall rule or whatever, and it's indeed quite funny when you wind up on a call with a prospect and they say, "Well, you're writing firewall rules," and you're like, "No, actually, we just allow you to write IP addresses into a list that it's pretty simple and pretty light touch, right?"
Yeah, precisely. We really take that least privilege principle. So we only want to add or remove IPs from a list that already exists. We don't want the permissions to do anything more than that because the firewall should be doing what it's doing, just have an IP list that we're managing dynamically.
Yeah, excellent.
So next example I'll show is the next one across, so SSH. Bastion host. So if I flip over here and try and SSH to it, I can't get it access. But you'll notice there's a grant access button on this one. So it's a bit of additional friction that has been configured. And rather than the default 7 hours, this one only has access for 2 hours after I've clicked grant access.
And to be clear, you could do that for any resource. If you want to make it click to grant access, that's just a setting.
Correct. Yeah, and obviously the period can be changed as well. So I've now got SSH access through this Bastion host. I click revoke access, and I can no longer get anywhere. So what's happening with this one is it's a little bit different. The example here is same server on hosted in Sydney, but on the right-hand side, North Virginia in Amazon, we've got a Linux VM, and the Knocknoc agent's running on the Linux VM, and it's updating IP addresses in the IP sets component of IP tables, netfilter, the sort of built-in Linux firewall, if you like, and it's adding my IP address to the rule around SSH. So there's no Palo Alto Fortinet, there's no other firewall. We're not using the AWS network security groups in this example, although we could. This is actually running on the host, and this is really good for Bastion hosts that are geographically diverse across the world because my user's connecting to Sydney to do the authentication side, opening up access, and then I'm directly connecting to AWS on the East Coast. Rather than any broker, cloud component or additional choke point of a VPN, I'm going directly through to that backend system that's being controlled through the Linux firewall.
Yeah, so this is very different to the sort of some of this remote access stuff that you might find from like Zscaler or Cloudflare, right? So it's not a magic cloud. You're not shunting all of the traffic through some sort of magic cloud. This is just enabling point-to-point connections.
Correct. Yeah, the orchestration agents open up access just in time, and then I go directly through to it. And the other important piece is I haven't installed anything. So my client user has not installed an agent or a client, VPN client, etc. It's going direct. All I've done is hit a web application that's then opened up access through the Knocknoc product.
Yeah, excellent.
So next one I'll show is a Windows console. So I click on this. This is actually bringing up Apache Guacamole, which is sitting in front of, in this example, a Windows machine. So I now have, and a lot sort of happened quickly there. But
yeah. And we should probably explain what Apache Guacamole is too, for those who are not familiar.
Yeah, so Apache Guacamole is a technology from within the Apache Foundation that allows you to broker, if you like, RDP and other protocols and give you an in-browser experience around that. So I'm still in Chrome. I have my other tab here where I've logged into Knocknoc. I've clicked on the link, it's opened a new tab, and it's allowed me to then go through and access RDP on this remote machine. And Apache Guacamole is a component that's doing some of that heavy lifting. So you can see, very responsive. Apache Guacamole is great. But importantly, if I log out of Knocknoc, flip back to this page and refresh, I no longer have access.
Yeah.
And you'll also notice here that I'm getting an error message now. Whereas before, when I was trying to ping, it was silently dropping the connection. When I was SSHing, it was also silently dropping the connection. Whereas this is actually giving you a HTTP response saying, hey, you can't access this, you need to knock before you enter. So it's a little bit a different way because it's HTTP, but it allows you to communicate to the end user, hey, you don't have access, go back and use Knocknoc. But equally, this could just be entirely timing out and invisible, like the ping and the SSH
that's up to you. But essentially, you've put a reverse proxy in front of this Windows box, which is running Apache Guacamole, and then you are like either allowing or denying access to resources through that reverse proxy based on what Knocknoc says is okay to do.
Precisely, which looks like this. So your server on your left, Singapore, Azure, in this example, we have the Knocknoc agent sitting alongside a reverse proxy. It's orchestrating that reverse proxy to then say, your IP address is allowed through to this backend machine. And because we're in the reverse proxy, we're also able to get at layer 7. So we can do path filtering, like /admin is allowed, but /public. /public is allowed, but /admin requires you to have a Knocknoc login.
Yeah, and there's some cool stuff coming too, because I'm going to kind of ruin the surprise a little bit here, which is that, for some people, they might say, well, that's really cool, being able to IP restrict our RDP in a just-in-time basis. Like, that's really cool. But if we have users regularly logging in from giant ISPs, like say in the developing world, where there's like, 500,000 people using that same IP address, and there's all of these compromised devices, that can egress via that IP address and connect to that resource, we feel a little bit uncomfortable for that. But you actually have a really wonderful solution for that, and that's this ID-aware proxy component of the product. Show us how that works, because you've got your sort of Akamai, Cloudflare, Zscaler approaches to this, which is the Magic Cloud approach. But then there's this, which is so much simpler and so much easier to implement than those things, which can be very fiddly. So walk us through that.
That's right. So I'll log in again as my user. And you'll notice there's a defense documents portal here, and it's got a little KAT next to it. So this one's available for 59 minutes. That's how it's configured. So I click this one. I load up this, awesome looking portal. Obviously, it's a bit of a demo and a mock-up.
Yeah, it's a ChatGPT vibe-coded thing that's designed to look as sensitive as possible, right?
Exactly, and it does. It looks awesome. But importantly, if I'm in that situation where I share an IP address with a hostile machine, targeted attacker, airport lounge, or CG in that example, I don't want my IP being permitted through to this application. So my IP is this 210 address, which is where I've logged in from. So I'm just going to bring up another browser on the same machine. In this example, I'm just going to log in as this demo 3 user, which is a local user. And I'm a local user. I have access for 3 hours, but you'll notice I'm on the same IP address. So if I'm to copy and paste this from Chrome, drop this in, let's just say that I'm from the same IP or even on the same machine, access denied.
Yeah.
And that's because it's not just doing IP level access, it's doing IP level plus we're injecting into the HTTP stream such that even on the same machine, same IP, you don't get access. We're doing IP plus what we're calling the Knocknoc access token, which really is URL, additional tokens in the URL, and then a bunch of session management that we dynamically orchestrate by the Knocknoc agent that is sitting alongside the reverse proxy. So here's the example of that one. Same server on your left. Singapore has some web servers on the right, and the Knocknoc agent is sort of orchestrating all of the token management, token creation management, and then session management to the backend applications, such that the user is still going direct, but their IP address plus token level filtering.
Now, the one annoying thing for a user there is if they want to access that resource, they have to click through from the Knocknoc page. Like, go back to that page because I want to show people this because it's super cool, right? So, yeah, once you click through there, you will have noticed that there is a string appended to that URL, and you can see it there, knock token, blah, whatever, right? So what they're doing is they're generating a token that is then passed via a URL into the reverse proxy. The reverse proxy sees that token, says, yes, that's the appropriate token that I'm expecting for this user, or that's a valid token. So then they set a session cookie into the user's browser, and then bang, you've got an authenticated browser session. And what's really cool about that is you can then, okay, so that's great. You're accessing a website. Cool, whatever. But you could do that with Apache Guacamole as well. So all of a sudden you can have web-enabled, like web trust-enabled, or, authenticated browser access to RDP, all pinned to SSO, which is just extremely cool. Now, in the examples you've shown, if someone from the same IP goes to that resource, they will get the HA proxy, sorry, you're not authenticated message. But you can even set this up such that they won't even be able to connect to that port. You can do it so that you're opening up the firewall to the proxy and then waiting for the token. Like, it's just very flexible the way you want to do it. But the point is, it is so much simpler than the way most people do IdeaWare proxies. Like, it is just made of win. I love this.
Yeah, that's great. It is simple. There is a bit of magic in the back end in terms of the orchestration, and those tokens come in, we immediately extinguish them so they're single use. As you said, we set up session management from there. But this sort of paves the way for other one-time pad style tokens to be created. As you sort of alluded to, we pass values back through to the underlying host that the agent's orchestrating that could then be a port knocking sequence if we want to go back to some of the fundamental roots of the idea. It could be data within a ping packet that is then observed passively and then, opens up access. So we're doing the out-of-band one-time pad, if you like, token distribution that can then be used in very interesting ways depending on the use case and how people want to implement it.
Yeah, so these Knocknoc access tokens are new. This is the immediate use case here, which is to get that like authenticated browser session happening, and from there, use it to access web applications. You can do it through like web SSH. You can also use Guacamole for things like RDP and whatnot. And I'm guessing there'll be other protocols added later, but there is certainly some flexibility here, I guess is the point.
Yeah, that's right. And we've got one customer who's not using the IP restriction component. They're just using the token component. So we can also split that out. So the system is public. It has a public-facing component. But as I mentioned earlier, the layer 7, so /admin/secret, needs the Knocknoc access token, whereas the public part of the website's not IP restricted. That's opened up. So a lot of different ways you can orchestrate at layer 7 in case of web and other protocols as well.
Yeah, I mean, one of the early use cases for this was like locking up like web hosting panels and stuff like that, stuff you just don't want on the internet. Probably a good time to mention too that there is a difference between, authentication and access control, right? Like they are not the same thing. If you've got a vulnerable web application out there, just because it's got authentication baked into it doesn't mean it's not full of remote code execution bugs, right, that people can exploit. So having those things locked away so they can't even be touched, before they're knocked, in this case, and then you can authenticate to them. I mean, it gets you a very long way.
That's right. And another implementation example is like sudo for web. So to log into the admin component of Knocknoc, which maybe we show now, to log into the admin component, you first have to go through the Knocknoc user level process, grant yourself access, and then you get access to /admin. So lots of different ways you can split out like normal user level access versus privileged access, or authorization to those resources as opposed to it just being an authentication or pre-authentication. So this is the admin experience. I've logged in, separate authentication. It can be a separate IDP as well. So you can have your user level with one IDP and your admin with a separate IDP, local users or combination thereof. So this is a quick example of I want to protect something. So I'm going to choose a firewall appliance. As mentioned before, we have the agents that talk to the firewalls, whereas this is a server that defines all of those rules. So I choose firewall, You'll see I've got three different types of firewall integration here. So I have passive, what we call passive plus, and active. Maybe I'll just quickly talk about those. So passive is the external dynamic list, or the EDL, which Palo Alto, Fortinet, many others have a solution for. And what it is Knocknoc publishes a list of IP addresses that are allowed, because remember we're in the allow listing state here. So it publishes a list of IP addresses that are allowed. The firewall then consumes that and applies that to one of the existing policies. So there might be
you can configure them to just periodically reach out to some list on the web where it just pulls it down and says, okay, they're the IP addresses that I'm allowing now, right? So, but I guess the disadvantage there, the advantage is for people who are in crazy compliance regimes, is there's no agent involved, and that makes them happy. The downside is that getting these firewalls to poll quickly, they don't always poll quickly, I guess. So users might be waiting, 30 to 60 seconds for their access.
Yeah, well, in some of them, the lowest level you can set it, or the highest frequency, is actually 5 minutes. So a user might be waiting up to 5 minutes to get access once they've logged into Knocknoc, which is, not ideal.
It's not ideal, but for some users who have really got like very paranoid compliance regimes, it's the only way they can do it.
Correct.
And it might be because they are looking to apply this protection to something very, very critical. So, it's like small volume of logins and compliance, and they just do it this way, and it's fine. It gets it done.
That's right. Some of the critical infrastructure customers are using this because they're in a data diode style world where they can't have agents internal to those systems, and this gives them the solution to that. So, but the downside is, as you say, you might have to wait up to 5 minutes. Active, on the other hand, is where we have our agent installed alongside the firewall. It does the orchestration through API typically, but it could be another way, SSH, if that's an approach that the firewall takes. And that's where the agent receives instruction and then goes and actively orchestrates it based on a user logging in. So that's the opposite, right? That's just as it's happening, it's creating that IP entry in the firewall for consumption within the policy. But there's sort of downsides of that as well. If you have hundreds of thousands of logins, or you don't want that interactivity. So we came up with the concept of Passive Plus, and what Passive Plus does is it mixes the two. So we publish an EDL. In this case, I'm showing the Palo Alto. So the Palo Alto is polling every 5 minutes, and it's getting that list down. But we also deploy an agent alongside the Palo Alto that goes and says to the Palo, hey, go and update that EDL. Go and update that EDL. The user's logged in. We've got a timer or a reason to go and do that. We've got activity. So it's still pulling the passive list, which could be tens of thousands of IP addresses, but we're telling it to go and do it now, as opposed to waiting, every 5 minutes or every hour to
you can kick it. That's the way I describe it. Is in Passive Plus, you publish the list and then you kick the firewall and go, hey, go get the list. What are you doing?
Yeah, that's right. Yeah, and it is, in a way, kicking works because we have very low privilege access here. So we only have the API user that is set up for this purpose that the agent uses for the orchestration is least privilege. It can only call the refresh API endpoint. It can't obviously log in or in any interactive access, but nor can it add or remove an IP address like the active integration can. It just goes and kicks it, as you say. But very simple to get set up. You put in the Palo Alto URLs in this example, supports Panorama, the relevant information depending on the policy or how you what it is that you're orchestrating and adding to. And then there could be a combination of these. So you can have, if you've got a hybrid environment of various vendors, you've got cloud, you've got NSGs, you've got on-premise firewalls. Depending on where you put the agent is where it could be configured and what it has access to orchestrate. Coming back to this sort of diagram where you have your server in one place that could be on the internet, could be internal, can be a combination, and then you've got Palo Alto integration on the top right, an endpoint Linux firewall on the bottom right. And then that reverse proxy example on the bottom left. So the user is at the center and has direct access through to these, and the agents are the thing that manage the state of all of that access.
Yeah, and that's the thing. That you don't have to just pick one thing. You can say we're going to use Knocknoc access tokens and that whole authenticated browser session over here for this RDP and these web applications. These things over here, the best we're going to do there is IP restrict them, but hey, it gets us a long way and we may as well do it because we've got Knocknoc, right? So you can sort of just pick and choose, pick and mix how you want to do all of this, which is, again, I dig it.
Yeah, that's right. But the other thing is it's not just inbound. So there's a lot of different environments, but you can also do outbound. So we have one customer who is protecting outbound access from, OT environment. They need to run updates periodically. They need to let those things escape out onto the wild, but otherwise they're firewalled off. So they're using Knocknoc to actually allow that transit outbound, as opposed to just inbound. So it's unidirectional. You can really just run it how you want to. You can run custom scripts as well, which is perhaps the next one I'll show. So custom script allows you to execute a script on an agent. It needs to be
so this is instead of like enabling access, you can get it to like do whatever you want, really. And I think there's one customer who uses this to turn on Wi-Fi interfaces at remote cellular base stations.
That's
so
right.
The Wi-Fi doesn't have to be up all of the time, but when they are going out to that site to do something, they can just turn on that interface with Knocknoc and then bang, they're on the Wi-Fi.
That's right. And after 4 hours, it turns itself off. They don't even need to remember to do that. So great solution.
But what other stuff do people do with the scripts?
Some people use it to do SSH, to use SSH to then log into various machines and do things. So it's not just the host that the agent's running on. But look, the way Knocknoc is built and designed is people self-host it, right? It's internal.
So
it's in their network.
You don't know what they're doing. Yeah.
We don't know. We don't want to know. We don't collect any of that data. What they do with it, they sometimes brag about their stories. Hey, we did this Wi-Fi thing. And we're like, oh, that's awesome. That's really cool. But other times it's, what they do with it is entirely up to them. But there's people that are deploying it to protect management networks, backup systems to stop lateral movement, even, rather than having a bunch of VLANs open, it's the new flat network. They're using Knocknoc to do just-in-time access through to the backup systems or through to, management networks. So lots of different use cases, and some of those are using scripting because they're executing things on other machines, not just the machine that Knocknoc's running on.
Yep.
But importantly, we allow environment variables, we capture data, we allow for the collection of data that's pushed through to the agent. So we pass through, the action and the username and the IP address obviously as part of this. But if you need to pass through tokens or other parameters to shell scripts, depending on what the Knocknoc is, that's all put here. And we encrypt those naturally, so we use the public key of the agent to encrypt those values, store them securely in the server, that the server then obviously can't read, but it pushes down to the agent on execution, which the agent then has a private component to decrypt and make use of. So that way we've segregated out where those tokens and permissions live. You don't need to have another HSM or another key management service necessarily as part of this. You can, but that way the secrets are stored in a secure way and provided just at the time of execution, and then can sort of be centrally managed through this admin console. And then the next step is to assign these out to who will use them. So there might be, my Joe demo user that I had. It could be out to SAML groups, depending on, what the IDP is passing through. And then that way, as the user logs in, they just naturally get that access provided to them. They may need to click to grant. There's other components where they need to engage. Otherwise, the access is provisioned. One other component perhaps to talk about, you mentioned some customers using our system in interesting ways, is we have an API. One of those is terminate user sessions. So you can create an API, it has IP restrictions out of the box, API keys for authentication to do so, and then we'll allow you to pass through a username, which will then go and terminate all of the Knocknoc sessions. So that's great for if there is signal, or if there's, as part of a detection response experience, you can go and sever those connections immediately. And then
how do you sever the authenticated browser connections though? Because if that's set up not to have the network enablement point of view, can you invalidate that cookie? I would have thought that'd be hard.
We can, because the session that is set up on the reverse proxy is still tied to the user's grant. So that's probably in the weeds a little bit, but we do actually track that. Not all proxies work that way.
Yeah, so as soon as that cookie's going through with every request kind of thing, right? So once it's gone, it's gone.
That's right. Once it's gone, it's gone. They get rejected and they need to go back to Knocknoc, re-authenticate, set up a new single-use token, go through that whole process again.
Okay, that makes sense. That's cool.
Yeah, so it terminates them at the network access control level, not obviously, the IDP is separate and ahead of this, but very effective in tearing that user's session down quickly as part of a response.
So yeah, just walk us back over to the core sort of page there where you could set up various things just so we can walk through them. Yeah, that one. Yeah, so you've got your Linux host / Linux firewall. So that's when you want to do something like, not instrument some pizza box firewall. That makes a lot of sense. So you could just do that directly on Linux. Firewalls and appliances. Then you got the HA proxy stuff, custom script and API we've covered. What's a Knock module?
Yeah, Knock module is we have a number of custom scripts, if you like, that are really wrapped up as a module. So that could be Juniper, SRX has a particular integration, Plesk, we've got an integration for Plesk. So really a Knock module is, a first-class script that we've created or worked with somebody to create that's then made available. So it's not a native integration, meaning it's not a Fortinet or Checkpoint integration where you just click next, configure the API key and away you go. It takes a little bit more work, but it's a script that the administrator will need to get involved in, maybe change around.
So it's perhaps referred to as other people's custom scripts that you might find useful.
That's right. But that we've vetted and we've made use of in places and that kind of thing, yeah.
Well, so there you have it. If you've got some vulnerable web applications you're looking to protect, if you just want to stop the entire internet being able to connect to all of your SSH all of the time, funnily enough, like one of Australia's major telcos uses this to restrict their SSH. You ain't getting SSH access unless you've been through Knocknoc first, and that's a lot of SSH that they have. There's so much you can do with this product. It's great. As Adam said, you hook it up to your IDP, whichever IDP it is that you want. You can also add local users, which is very useful for like remote users who are maybe outside the organization, contractors, things like that. You can still provision them username and password access. But I think, that wraps up the demo. Adam Pointon, thank you so much for joining me to walk through it all for the audience. I mean, I know this product well, and I'm just so stoked to be able to share it with everyone. Great to talk to you, man, and we'll be speaking to you in the regular podcast real soon. Cheers.
Great. Thanks, Patrick.